Hello, beautiful people watching this video. Thank you for watching this video. I appreciate it. If you've already made it this far in the video, you rock. Today is, well, when I'm going to sign this is May 6, 2020, page 59. We're still in my makeup room. Not makeup room, on my makeup table, which is funny because I don't even do makeup that much. Okay, today we are learning about probability models. So, the last video we were talking about making predictions using probability. This time we're talking about making probability models. Sounds scary? It's not scary at all. There's literally one fact you need to know, and then you're good to go, and we're just going to practice. So, what is that one fact? That one fact is the sum of the probabilities listed in a probability model must equal 1 or 100%. So this is crucial. This is critical. You have to know this. You need to write this in your notes. The sum. So when you add, sum means add. So when you add up the probabilities in a probability model, so when you add all probabilities, they must equal 1. So the probability has to equal 1. We know 1 as a percent is 100%. So 1 or 100%. Or if it's a fraction, it needs to be like 1 out of 1 or 2 out of 2. So when you add up all probabilities, they have to equal 1. 1 is the same as 100%, which is the same as 1 out of 1. That is the fact you have to know, and from there on out, we can just practice them. So, example 1. Michael, Ronald, Lydia, Alexandra, and Catherine are sharing a basket of fries. The following table shows an incomplete probability model for who will eat the next fry. So, Michael, 0.3. Ronald, we don't know. Lydia, 0.1. Alexandra, 0.32. Catherine, 0.1. What is the probability that Ronald will eat the next fry? So, in your notes, you should write down this table and the question. What is the probability that Ronald will eat the next fry? Okay, so what you have to know, they have to add up to 1. Okay, so right now we're going to add up what we already have. Right now we already have 0.3, 0.1, 0.32, and 0.1. You can add them up with a calculator or you can add them up by hand. If you add them by hand, you have to remember, line up the decimals, and then there's invisible zeros here. 0 plus 0 plus 2 plus 0 is 2. 3 plus 1 is 4. 5, 6, 7, 8. Bring down the decimal. 0. So right now, the 1, 2, 3, 4 that we have is 0.82. We want to know what goes here for Ronald. Well, they have to add up to 1. We already have 0.82 and they have to add up to 1. So how much is left? So if 1 is the total that they have to add up to, 1 or 1.00, and we already have 0.82, how much is left for Ronald? Subtract. (10 minus 2 is 8. 9 minus 8 is 1. Bring down the decimal. 0. So what's the probability that Ronald will eat the next fry? 0.00. 0.18. So, probability Ronald equals 0.18. So that means that 0.18 would go right here. Okay, if decimals aren't easy for you, guys, you could always convert these to percentages. Move the decimal 2 times to the right. That's 30%. 2 to the right. 10%. 32%. 10%. 30, 40, 50, 60, 72, 82. We have 82%, and we have to get to 100%. So 100% minus 82% still leaves us 18%, which is 0.18. So if you're not comfortable with decimals, make it into percents. But honestly, if they give it to you in decimals, it's just easiest to leave it in decimals. All right, let's go on to the next one. So this time we have fractions. All right, so we have this table of these 4 different friends that are going on a road trip. And it's basically the probability of who's going to be driving. So we want to know what's the probability that Avel will be driving during any given kilometer. So basically, we need to fill in this question mark. Once again, you could change these all to percentages. You could do 1 divided by 8, write it as a percent. 3 divided by 8, write it as a percent. 1 divided by 8, write it as a percent. Add them up and subtract it from 100%. That's more time consuming. I don't recommend it. What I recommend is just leaving them in the type of number that they give it to you. So they gave us these in fractions. Right now we have 1/8, 3/8, and 1/8. And we know that all 4 of these have to add up to 1. So right now we have, well, they already have a common denominator. Awesome. So we just leave it. So out of these 8 pieces, we already have 1, 2, 3, 4, 5. Right now we have 5/8. Remember, when you're adding fractions, if they have the same denominator, you just leave it because it's broken into eighths. So like if you have a Pop-Tart and it's broken into eighths, we have 1/8, 3/8, so 1, 2, 3, and 1 more eighth. So right now we have 5 out of 8 pieces. 1, 2, 3, 4, 5. So how much is left for Avel? Well, 1, 2, 3 out of 8. If you don't want to do it with a model, you could just do, we know that a total, 1 whole, is 8 out of 8 pieces. Okay? We already have 5 out of 8. So how much is left? Subtract. Common denominator. 8 minus 5 is 3. So 3/8. So what's the probability that Avel will drive next? 3 out of 8. Now for these questions, these ones are multiple choice. I believe they'll just leave it in the number type that they gave it to you. So if they give it to you in a decimal, they're going to give it to the answer in a decimal. If the problem has fractions, the answer choice will have a fraction. The main thing you have to know, the model has to add up to 1, 100%. Number 3. Justin, Cam, and Ben are playing a board game where exactly 1 player will win. Ben estimates that Justin has a 20% chance. So Justin, 20%. So I'm just going to write that down. So probability of Justin is, so equals 20%. Oh my goodness, you can't even see. Okay. Cam has a 50% chance. Oh, nice, Cam. Okay. Probability of Cam is 50%. Okay, so we have Justin, Cam, and Ben. So what's the probability that Ben will win the board game? So probability of Ben. Well, we know that total, all three of their percentages have to add up to 1 or 100%. So total, it has to be 100%. We have 20 plus 50. So right now we have 20 plus 50, 70%. Now, if we already have 70%, in total we need 100%, how much is left? We already have 70%, in total we need 100%. So 100 minus the 70 that we already have, 30%. So that leaves us 30% probability for Ben. Check it. 20 plus 50 is 70, 80, 90, 100. It adds up to 100%. We're going to do 2 more because I want to make sure I hit every single type that they show you on Khan Academy. So, same page in the notebook. So sometimes they might give you a graph, like a bar model, and you have to figure it out given the bar model. So we have Sports World, and it's open every day. I'm just gonna confess to you guys, I'm guilty. I really don't read this a lot, and that's not good. I just kind of look at it, and I need to improve on that. Chelsea, Ivy, and James are the only employees at Sports World who can open the store. So they have the keys. Chelsea, Ivy, and James. The following graph shows an incomplete probability model. We know probability model, total equals 1 or 100% for who will open the store. Okay, what is the probability that James will open the store on any given day? Well, let's see what we already have. The probability of Chelsea, actually, I want you guys to pause this. Try to do it on your own. You guys have enough information now to try to solve this on your own. You know that all 3 of these bars have to add up to 1 or 100%. So try your best to do it on your own and then check back in. So Chelsea, the probability of Chelsea, okay, 0.3. Or if you like it as a percent, change it to the right and it's 30%. The probability of Ivy, $0.1. If you like it as a percent, you move the decimal 2 times to the right and it's 10%. And now we need to find what is the probability of James. Well, we know that total, these 3 bars, these 3 numbers have to add up to 100% or 1. They're in decimals, so it's 1 that we're focusing on. Right now we have 0.3 and 0.1. 3 plus 1 is 4. Bring down the decimal and the 0. Right now we have 0.4. So we have a 40% chance that it'll be one of these 2. So how much is left for James? Well, total it has to be 1, and we have 0.4. So 1 minus 0.4. You can do it by hand, or you can use your calculator. 1 minus 0.4, 0.6. I recommend always checking. So 3 plus 1 is 4, 5, 6, 7, 8, 9, 10. So 0.3 plus 0.1 plus 0.6 is 1. Perfect. So James's bar, if you had to draw it, would be 0.6, which is right here. All right, so the last problem we're going to do, and then we have covered all the types you should see in the Khan Academy assignment titled Probability Models. Probability models to me are kind of fun. I don't know, I really like them. Dahlia owns a gravel pit. Gravel pit. She took a random sample, we love randomness, awesome, of rocks and counted 58 sedimentary rocks, 213 metamorphic rocks, and 522 igneous rocks. Use the observed frequencies. So we're going to use the observed frequencies. So how often she picked each one. And we're going to create a probability model for Dahlia. Okay. We can do it as fractions or as decimals rounded to the nearest hundredth. So 2 decimal places. So sedimentary. So what's the estimated probability of Dahlia drawing sedimentary? Well, how many were sedimentary? 58. Out of how many total? Well, what was the total? They didn't tell us, so we have to add up those numbers. So 58 plus 213 plus 522, 793. So I'm going to write total rocks was 793. So she drew 58 sedimentary rocks out of 793 rocks. You can leave it just like that. That's how I would input my answer. Fractions are always more accurate than changing it to a decimal, because changing this to a decimal, it's going to be 58, fraction means divide, 793. So then you have to put 0.07 because it says the hundredth. And honestly, those other numbers are important. So I would just recommend leaving it as a fraction when it gives you that option. So metamorphic. Probability of metamorphic rock. So how many are metamorphic? 213 out of how many rocks total? 793. And then the last one, igneous. You guys should be able to do this one on your own. How many are igneous out of how many rocks total? 522 out of 793. So by far, igneous is the most likely because she drew the most igneous rocks, where sedimentary was only 58 of them. So 522 out of divided by 793. So if you times that by 100, change it to a decimal, a percent, that's 65.8%. So that's very likely that she's going to get igneous. So when they give you the empty table like this, all they want you to do is fill in the estimated probabilities, because that's how you do a probability model. Because if we added these up, these fractions, 58 out of 793 plus 213 out of 793 plus 522 out of 793, total, those numerators add up to 793 out of 793, which is indeed 1. So that's how you check. So, literally the main thing you have to know for probability models, the main thing, when you add all probabilities, they must equal 1, which as a percent is 100%, as a fraction is 1 out of 1, 2 out of 2, 1,000 out of 1,000. Okay, let's crush it. Let's kill it. I love you. Goodbye.